Many students in Chem 3A are interested in various health fields, and so radioactivity in medicine is probably a topic that's interesting to you. Still not working. So isotope scanning is one use of radiation in medicine. So this picture here is showing a bone scan where the radioactive isotope technetium-99 is administered to the patient, and then that's distributed throughout your body, and then either a scintillation counter or photographic film will take a picture like this and show where the technetium-99 has been concentrated. And based on where that isotope goes, the doctor, looking at evaluating the scan, can ascertain what's going on with your bones. Radiation is often used for cancer because it is especially effective at killing rapidly dividing cells, which is what cancer is. It's rapidly dividing cells. Cells are reproducing out of control. So you can take a beam of gamma rays, which have high penetrating power. They'll go through your head, no problem. And so you shoot a beam of gamma rays and hit the tumor. Now, that damages the tumor. It also damages the rest of the tissue that it's going through. So you can't just have the beam in one place and zap out the tumor, because you're also going to zap out a hole through the person's head. Not literally, but you're going to destroy those cells. They have a better picture? No, they don't. But they take the gamma ray and they move it around. I'm going to draw a picture, if it'll let me. That's not what I wanted to do. Okay. So let's say that this is a person's head, and there's a tumor in here. And we want to get rid of the tumor. So we're going to shoot a gamma ray in here to hit the tumor. I almost missed the tumor, but you get the idea. And then I'm going to do it again from this direction, and from this direction, and from this direction. And we're going to shoot the gamma rays in from different positions, but all focused on the tumor. So the tissue over here will get some damage, and the tissue here and here and here, but the tumor gets the effect of all of those rays. And so this is a way to maximize the damage to the tumor and minimize the damage to healthy tissue. Now, if you know someone who's had radiation therapy for cancer, you know that it can really do a number on you. It can cause your hair to fall out because your hair is composed of rapidly dividing cells. It just keeps growing, right? It can mess with your fingernails, your eyelashes, various things like that. As with everything in medicine, it's balancing the risk and the benefit, right? And sometimes in order to cure the disease, you have to do some damage. You know, if you have appendicitis, you need your appendix removed. They're going to have to cut you open. Is that good for you?
Yeah.
Cutting you open?
No, because you're putting under.
Yeah, you're going to have to be under general anesthesia, and then you're going to have this incision that needs to heal. But if you don't do that, the person's probably going to die because their appendix will rupture and spread that infection everywhere, and they're dead. So the same idea with cancer. Yeah, we're going to do some damage trying to kill the cancer. But if done properly, overall the benefit is greater than the harm done. Any questions?